Hello viewers, welcome to my channel Science and Technology. In today's show, Rocket Monday, we're going to talk about Honda's reusable rocket test bed. So let's dive deep into it. Now let's understand what the heck is Honda. Honda is a mobility company and it's an old puppy. As in Japan 1946, they actually made a motorcycle. As in like they had a cycle, they put a motor into it. And yes, engines are called motors. Don't ask me why. But it's not a battery powered motor. So that's how they got their start. Now they are a big name now. They started very small and humble, but they are a big puppy now, as in $90 billion big. So they're big. And here's still, many companies could have ludicrously larger ratings, but their revenue profit is very low. Yeah, this puppy has $7.6 billion in revenue in 2024 alone. So they're good. Let me put it there, like they are so big in terms of scale and profitability that they can run a space program on a side. So they can do that. And they announced this puppy in 2021 that they're going to move towards space. Now, they are saying it will support their goals of mobility, with too much exaggeration, but okay. The primary reason is working with JAXA, as in Japan has a lot of technological horsepower. But when it comes to their rocket, yeah, they're lightweight. Like they're really lightweight, meaning if you want to launch some big loads, it's like, yeah, it might take 4 years to make one tiny rocket that can do that. So yeah, they're not good. Like in space technology, they're good. In terms of space horsepower, infrastructure, launch cadence, it's not even comparable. So JAXA started to create a feeler network for almost all bigger players in Japan. It's like, hey, can you actually turbocharge the private network? So okay, cool, awesome. But what does Japan bring to the table that is unique to them? Well, first, technology. You have to understand Japan is very serious hub for technology, and on top of that, Honda has a lot of patents and lot of actual experience with patents, because again, patent expire in 20 years, so that's not a big deal. But the fact that they have expertise in manufacturing certain unique things, and be mindful, they manufacture aviation, as in they have private jet fleet from start to finish in-house built. So they have very serious horsepower, and they have this high differential pressure water electrolysis system, which again JAXA is very interested for lunar colony missions. So there is a lot of stuff that Honda can bring to the table in terms of technology. That's like, it's good to have them. It's like, it's good to have someone who knows how to deal with radar. It's good to know someone who deals with aerospace rules and regulation. Like there is some technological portfolio benefit. On top of that, they are daddy of mass production expertise, meaning making one rocket will take them their sweet time. But here's the moment they are done with that one rocket, they're like, yeah, how many you want? Oh, 10. Yeah, take 100, man. Like, ain't nobody get time for that. Take 100. So they do have certain unique abilities, so to say. So that's why it is not a laughing matter. It's like serious. Okay, why now? As in, like, why this sort of things are happening? Well, reality is space access is becoming what we call a routine. As in, there is a space industry before SpaceX, there is space industry after SpaceX. And it has reached what we classify as high maturity and refinement level. Meaning, if your rocket is not working, you are at fault. Like flat out, you are at fault, not anyone else. Is like, rocket technology is sorted. It's the same thing. You build it first or you build it better. So first part is done. SpaceX was the first part, as in like, oh, can a private company work? Can a private company do something that nobody has ever dared to do? Oh, they did it. So things have changed. Now, Japan does not have enough horsepower when it comes to putting tonnage into low Earth orbit. It just does not. Like it has have some good portfolio for rocket. It's just like, it's not there. Let's just put it there. It's not there. So, and again, they are trying to cultivate private players, but then it gets the chicken and egg scenario. The reason why SpaceX could work, because there was NASA funding the budget, like a very large budget, as in commercial resupply mission kind of budget. JAXA does not have that kind of flexibility. So they do not have the oomph where they're like, okay, you build it, I'll buy it. They don't have that luxury. So going into this sort of established partner, even on memorandum of understanding rather than like actual contract, that can get some serious dough into the mix. So they have realized this, like they need some serious money. And Honda does have many technologies that are low value on Earth, as in like, oh, how to make like, let's say, good low resolution radar and all that, or good high frequency radar and all that. Cool, awesome, GG. How much you are paying for? $1 million. Okay, take the same technology, exact same thing, copy paste it into space industry. Yeah, $1 billion. So all their technological portfolio that they have, again, making a fuel cell on Earth, take it and go. Making a fuel cell that can work on Moon, shut up, take money. So that's the whole point. Their whole portfolio stack, as in like a corporation point of view, becomes priceless. It's like, shut up, take money. So that's their economic point of view. That's how they can justify to their shareholders that this is not a short-term project, but long-term amplifier. Basically, everything we do for basically ground-based system, it will be transferred to space-based system, and it will get multiplied by 10 in terms of profitability. So there is a genuine advantage there from Honda's point of view, from long-term future stability point of view. And they have time, money, and buyers ready to go. Time, that's the gold part. Like, if you look into their pipeline, they're like, bro, chill, man. It's like startups, they have to go very quickly because, again, they will run out of runway. They have the runway. They're like, bro, we make the runway as we are going. So even if they have to burn $500 million annually, that would be like, bruh, minor inconvenience. So that's not an issue. So time and money is sorted for them, and they have buyers. As in, like, JAXA is a big company, a company as in like a agency that is like, bro, we have something, like at least sell something and we're gonna buy it. Like that part is sorted. So there is a good what you call fertile environment at this point in time. So let's understand this test bed. Now this puppy is 6.3 meter tall, not very tall, and 0.8 meter in diameter. So it's yo big. Mass ratio is odd. That's why I'm saying it's a test bed. It's not even designed. I thought originally, by the looks of it, it looked like it's a rocket that has been removed of this payload or second stage or something like that. No, it's not something like that. It's designed from starter to finish to be a test bed. So mass ratio is very poor. As in, like, the dry weight is 900 kilos and wet weight is only 1.3. That's bad. That's just bad. To give you a context, like, what does that number means? Divide those number and you'll get 1.46, and that's low for a flight-based rocket. Good for testing and like a grasshopper, but not for flight. To give you a contrast, the closest rocket to this is New Shepard. Now, New Shepard, that is 3.4, and that's a suborbital human launch vehicle. So you can understand that number has to be high. And what about orbital? Orbital does have a problem that because they have two stage, both stages generally have a different dry to weight ratio. So Electron generally goes to 7.6. Now you're like, isn't that low? Yeah, the first stage is lower, but the second stage is higher. So that's decent kind of system. And again, the bigger the rocket, the better this becomes. So you get the point. Like, this is a test bed. Do not really, oh, it's a rocket ready to go. No, 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 no. It's just a test bed. And one unique thing that they did manage to do that I have to say, damn, is that they took off on the legs directly. As in, the legs were deployed and it was on a stool, because they wanted to make sure there was enough clearance for rocket exhaust. There was on a stool and it took off from the stool. There was no structure like a, basically New Glenn requires a complex structure, a launch mount. It did not require that. It was just like, I'm standing on a hole, and of course it would require a hole for like exhaust clearance, but it can take off. Like, as long as you can place it on a hole, it can just go yeet and it can land. So this was the test bed. And again, grid fins are just for showcasing that their algorithm is stable enough that it can handle those things. It will not do anything in terms of aerodynamics. It's like, it's not for that. So, okay, they made it, they got the money. What's the result? Well, 17 June 2025, Honda facility in Techlity Town. This place, basically, they launched it and they had a 1 kilometer no-fly zone, so to say, or basically no people zone. And here's the funny thing. I was like, okay, who decided in Japan? I thought it would be JAXA. No, Cabinet Office of Government of Japan. What? I have no idea why they were involved, but they were involved. It's like they were the one, like, Honda worked with them. It's like, okay, this is our boom potential, how much boom it can do. So they're like, okay, you have to give us at least 1 kilometer of no people zone for safety. And again, they had water sprinkler running around. So in case rocket goes kaboom and falls on foliage, it should not catch on fire. So that was done. Now they did, put it, launched it, and you can see like that small peg that they were standing on. Altitude was 271 meters, so to say. So that was decent. I think their target was 300, and their flight time was 56 seconds, 1 minute. So decent for a test bed. And landing was surprisingly accurate. This is why I said, like, the fact that they have radar technology. It was 37 centimeter off target. Now, like, okay, is that good or bad? Here's the deal. 37 centimeter on a rocket that diameter is 1 meter. That's precise. That's like you're landing in a hole. That's precise. So everything combined, it's smooth operation. Nothing was like whoa, everything was like smooth. It's supposed to do that, it did that. It deployed the landing fins, it did that. It's supposed to deploy the leg, it did that. It's supposed to bounce on the leg, it did that. Everything about this was smooth. That's the one way to describe it. And you must have seen recently a lot of small startup companies that are trying, and their first launch is like kaboom. So compared to that, to this, it's like, this is like they know what they are doing. Be mindful, there is one YouTuber claiming that they have footage of basically 2021 rocket engine testing. It's not, it's someone else's rocket engine testing, because again, Honda did not share it. So you can see like, oh, by the way, you can go into Honda website and they will share all the data. That's how I got it. So question is, what can we expect in the future? Well, reality is, Honda has the money and the runway to basically take it slow. They are not rushing it. And it shows in their own basically target points, basically the targets that they are showcasing and dealing with public as in shareholders. That target is, we're going to be very slow, as in our aim is suborbital by 2029. They're slow. As in, I've seen like a lot of private startup companies, even they are like, bro, that's slow. You're basically making a sounding rocket by 2029. So they are taking it slow. Now, why can they take it slow? Because they have the money. And again, having a large corporation, you do not want to bankroll the whole damn thing unless you are Jeff Bezos. So they're like, they're doing it cautiously, so to say. Now, Japan needs launch provider, flat out. Like they got the technology, it's just that they do not have the oomph, the horsepower. So they need that, flat out. Now, this will not compete with US. Let that be very clear. If you're thinking, oh, this is going to be awesome. Again, 2029. If things go even remotely well, 2029, US companies should have lunar landing sorted. As in like, take it and go. Lunar landing is a thing that we just do. Like, ta-da. So, and again, I'm not talking about human landing. There are so many companies whose sole provider, we're going to land on the moon. And they are brute forcing it, as in like have 5 to 6 companies specializing on that. So that's not a threat to US system. Again, US is way further ahead, and that's why Japan is trying to get their automobile people to like, bro, you guys are good, you guys are sorted, try to cook it. Because again, private companies require a lot of money, startups require a lot of runway, and short runway generally means bankruptcy. So they're taking it slow. And right now, even Electron will look like it. Bro, what are you doing? And again, knock on wood, I'm thinking about buying Electron Rocket Labs stock. Is that they should have Neutron sorted by 2029. It should be like, bro, done, like done, sorted. So that is there. And one mathematical thing you have to understand: small launchers are not profitable. Like flat out, from economics point of view, it's not logical to launch small sats. It makes sense in back in the days. Now it does not make sense. And to give you a context, look into SpaceX. What did they do? Falcon 1, launch it. Cool, awesome. What did they do after that? They're supposed to make Falcon 5. They yeeted that, jumped into Falcon 9. Look into Rocket Lab. Again, they made an Electron rocket. Everything's fine. What's the next thing? Neutron rocket. Make it as big as possible. Everybody. The same goes with basically Blue Origin. They had a small sub-orbital system. Again, TestBed and all that. What was another? Heavy lift rocket. Like there are certain economic vectors that makes a small rocket illogical. Like from economics point of view, it's stupid to launch small rockets. Again, good for training, good for learning, good for Mark 1 product. But that can't be your only product portfolio. So that's the whole point. They're like, we have good experience with aerodynamics, so aka fluids, combustion control, and combustion analysis. I'm like, that's stretching it. Like again, I'm also working with engines, so like combustion complex, GG. Rocket exhaust is different, man. Like that's different. I'm like, I get it, like cool, but like Honda, come on. Engine exhaust is not rocket exhaust. It's like, bro, you are like orders of magnitude off. But again, I get it. At least they have good chemist. So that is there. And again, technological to recognize external environment and vehicle itself, LiDAR system, so to say. So they do have good portfolio, which could translate to a good thing. But again, it's a very slow, very methodic process. So relax, don't worry about it. You might hear about it in 2029 or maybe 2030. So just, it's a thing that is a small thing that is being done. So Japan in future by let's say 2035 should have a bit more of oomfish present in a space rather than can launch it or not. So this was my presentation on basically Honda's a reusable test platform. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.